Welcome back to next session. So here we are going to see another type of sensor, encoders. So encoders are three types. All three types we are going to cover in this session. So this is the encoder, optical, magnetic and capacitive type encoders. These three we shall complete now. So optical encoder. An encoder is a device that provides a digital output as a result of an angular or linear displacement. Position encoders can be grouped into two categories. One is incremental encoders and another one is absolute encoders. Incremental encoders detect changes in displacement from same datum position. So from reference position, that is incremental encoders from same datum, whereas absolute encoders give the actual position. Incremental encoders, first we will see the incremental type. It consists of a disk which rotates along with the shaft. The rotatable disc has a number of windows through which a beam of light, these windows are known as apertures, a beam of light can pass and can be detected by a suitable light sensor. So there is a light encoder, optical encoder. When the shaft rotates, the disc rotates. So here that way these two are interrelated. A pulsed output is produced by the sensor with the number of pulses being proportional to the angle through which the disc rotates. Incremental encoder for the measurement of angular displacement of a shaft. You can see here, this is the disc having apertures. These are also known as windows. And here this is the rotating disc and rotating shaft on which this disc is mounted, and this is the detector and the light. When light is made pass through this apertures, and this is having single aperture, and this disc is having single aperture, and whereas this is having number of apertures. When it rotates, when the light passes through these two apertures, then that will be detected, and that is having one resolution count. It will be having one resolution count if it matches with this aperture. Then light will be detected, and it comes to know that one revolution is completed. So that is how it works. Incremental encoder. The angular displacement of the disk can be determined by the number of pulses produced in the angular displacement from same datum position. Typically, the number of windows on the disk varies from 60 to over 1,000, with the multi-tracks having slightly offset slots in each track. With the 60 slots occurring with one revolution, then one revolution is a rotation of 360 degrees. The minimum angular displacement, that is the resolution that can be detected, is 360 divided by 60, so that is 6 degrees can be detected. The resolution thus typically varies from 6 degrees to 0.3 degrees, even better than this. With the incremental encoder, the number of pulses counted gives the angular displacement. A displacement of say 50 degrees, giving the same number of pulses, whatever angular position the shaft starts its rotation from. So that is resolution of rotating disc or incremental encoder. And the next diagram, it will be clear how the tracks are measured. This is absolute encoder. So the absolute encoder gives an output in the form of binary number of several digits, each such representing a particular angular position. So here it is having the tracks are seen here. You can see here, this is 0, this is completely 0, and one is having the light passes through this, and another are all other three are having null position. Light is not passing through this, and it is the second one is opened here. The first one and second one is open here. First two are closed, third one is open here. So like that you have grayscale. This is known as grayscale formation. So this is 0 1, and this is 1 0, this is 1 1, this is 1 0 0, this is 1 0 1. Like that you have the disk pattern, and you can see the four detectors, bank of four detectors. Light when passes through, it will be continuously passing through from this disk. When the opening number of openings, the opening on each track is detected by this bank of four detectors. The output from the four detectors depending on the position of the disk. So the position of this disk is easily measured, and these are the apertures. These are the apertures here. Each arc has a unique set of apertures. So that is the aperture. Aperture, or it can be called as window also. In practice, a modified form of binary code called the gray code is generally used. So this is four digits gray code. This code, unlike normal binary, has only one bit changing in moving from one number to another. So we have 0 0 and then one bit change, and another one bit change, one bit change. So from one position to next position there is a one bit change. That is known as gray code. The rotating disk has four concentric circles of slots and four sensors to detect the light pulses. The slots are arranged in such a way that this sequential output from the sensors is a number in the binary code. Each such number corresponding to a particular angular position. A number of forms of binary code are used. Typical encoders tend to have up to 10 or 12 tracks. The number of bits in the binary number will be equal to the number of tracks. So here this is the resolution 0.35 degrees. So that is very fine resolution you can get using this. So a simple example is given here. The incremental encoder and the absolute encoder can be used with linear displacements. If the linear displacement is first converted to a rotary motion by means of a tracking wheel. So here this is the rotational displacement and the tracking wheel, and this is the linear displacement. So magnetic encoder, the next one is magnetic encoder. The magnetic encoder consists of a rotating gear made of ferrous metal and a magnetic pickup that contains a permanent magnet and sensing element. So here this is the rotating disc having the teeth, and it is the magnetic pickup get teeth ferrous metal. So here this is the from this shaft it is getting rotated. So magnetic pickup will measure the teeth on the wheel by magnetic flux, and that is measured, and as the disc rotates, these teeth disturb the magnetic flux emitted by the permanent magnet, causing the flux field to expand and collapse. These changes in the field are sensed by the sensing element, which generates a corresponding digital or pulse signal output. So normally this produces the digital output directly because these are the transducers. Two kinds of magnetic pickups used in this. One is a Hall effect and another one is variable reluctance. Hall effect pickups use a semiconducting sensing element that relies on the Hall effect to generate a pulse for every gear tooth and passes the pickup. Variable reluctance pickups use a simple coil of wire in magnetic field. As the gear teeth passes by the pickup and disturb the flux, they cause a change in the reluctance of the gear magnet system. This induces a voltage pulse in the sensing coil that is proportional to the rate flux change. So this is a variable reluctance type. These are the two types of pickups used. And next is inductive type encoder. Inductive encoders can be thought as a hybrid of a resolver and an optical encoder. So it is a hybrid of these two technologies, like a resolver and optical encoder. And inductive encoder are encoders. These are also known as encoders. Use the same basic physics as a resolver, but are less costly, lighter, more compact and more accurate. Importantly, they are also easier to use because they only require a DC supply and output as a digital signal representing absolute angle, like a absolute optical encoder. The skills issue is eradicated because the inductive encoders do not require separate electronics processing circuitry. All the necessary electronics are integrated in the inductive encoders stator. This means that encoders have all the advantages of resolvers, but with none of their disadvantages. So all advantages are taken from the resolvers, but disadvantages are actually eliminated here. Because inductive encoders do not use delicate optical components, they are not susceptible to foreign matter and do not only operate in limited temperature ranges. Inductive encoders instances, they have been used at temperatures of up to 230 degrees centigrade or Celsius. So that is a very high temperature in this environment also. These can be used. So rather than the traditional resolvers, copper wire windings, encoders use printed circuit boards, PCB boards as their main components. As with a resolver, there is a stator and a rotor, but because there is no requirement for precise location of stator and rotor, there is no need for any bearings. So bearings are not required here. Since encoders are printed circuit boards rather than wire windings, this means that they can offer extremely high accuracy. This is the very huge advantage here. The basic design of an encoder also means that it can be readily customized to suit a particular application's requirements. Encoders are available in wide range of sizes up to 600 mm diameter and have been used extensively in a variety of machine tools, gimbals, aerospace, defense and medical equipment. So these are all the applications. And next we will see the capacitive encoder. So capacitive encoder here, it generates output code through detecting changes in capacitance using a high frequency reference signal. As a asymmetrical shaped disk is rotating through within the encoder, this disk will change the capacitance between two electrodes, which can be measured and calculated back to an angular value. So angular value can be computed from its measured value. And then the capacitive encoders are relatively new compared to other types. It is a relatively new technology. The technology has been used for years in digital calipers and has proven to be highly reliable and accurate. And this is a simple type of capacitive encoder. Capacitance principle is employed here, and encoders, its applications we'll see in next slide. In automotive applications, in automotive industry, encoders are used for mechanical motion, for controlling speed, Consumer electronics and office equipment. In consumer electronics, encoders are used in office equipment such as PC-based scanning equipment, scanners and printers. Industrial in the industrial area, encoders are used in conveyors, labeling and packaging machines and machine tool with a single and multi-axis controllers. In medical area, encoders are used in medical scanners, dispensing pumps and microscopic or nanoscopic motion control of automated devices. Scientific instruments often implement magnetic encoders to position observatory telescopes. And applications wise, if you see assembly machines, testing machines, robotics, drilling machines, packaging CNC machines, labeling machines, motor feedback, X-ray machinery systems, laboratory instruments, medical equipment, scientific instruments, textiles, conveyor systems, printers, etc., etc., etc. There are so many applications. Then advantages and disadvantages, if you see, withstand contaminants such as dirt, dust, moisture, water and temperature changes, greater reliability and durability, integrated electronics, compact in size, encoders having very good advantages than disadvantages. The disadvantages are limited, subject to radio and magnetic interferences, variable resolutions, sensitivity to temperature effects. So these are the limited disadvantages, and you can refer the same textbooks, Dublin and Patranivas, for these topics, and also you can see the A.K. Ghosh instrumentation and control book. That is also a very nice book. Okay, students, thank you. We will see in next session. Thank you, students.